Hi guys, my name is Eduardo Cárdenas and welcome to this new video Max. This practice number 2 is practically the previous one, only we will use the for structure.
Guys, as you could see in the previous video, we made a sequence of LEDs in a vulgar way because we wrote the power and weight codes for each LED. Now we will carry out of this practice but using control structures. The control structures are instructions that allow breaking the sequentiality of the execution of a program. This means that a control structure allows some instructions to be carried out and others to be omitted, according to the evaluation of a condition.
The same components as practice number 1 will be used. In short, the same configuration of the previous practice will be respected. If you haven't seen the practice 1, I recommend you see it. I'll leave the link in the description. The exercise 2 say, make a program using arrays that lights up the LEDs from top to bottom and then goes backwards so only one LED is on at any time. This is often called a silent or a Larson light. But we have a challenge. Make a program that lights up the LEDs in any pattern that you like. Next, we will explain the code. The first thing we do is declare a global variable, which is the number of LEDs that we are going to use. In this case, there are 8. Later, we declare an array to simplify the task of declaring one by one of the LEDs. In this case, within of the array, we will add the digital pins used in each LED. We use 2 to 9 pins. Inside the body of void setup, we will put a control structure, in this case, for loop, of which we declare a local variable, in this case, with the letter I. The for loop contains a condition that is divided into 3 arguments. The first one is what number it's going to start with, in this case, with number 0, because the array starts to come from 0. Later, it explains how many times it's going to perform the cycle. As there are 8 LEDs, we'll add that the cycles are less than the number of LEDs, so that the last number is 7. The last argument is to tell the cycle if the count is going to decrease or increase. In our case, it's increasing. As can be appreciated, it's only to declare the exit pins, so not to gain it one by one. Inside the body of the loop, we will add the cycle so that all the LEDs turn on. As the first argument, we say that it starts at 0, that number is repeated before the number of LEDs, and that it goes from 0 to 7, that it's increasing. We will add a timeout of 0.1 seconds to better see the cyclone effect. As can be seen, in the for ignition cycle, we don't perform the action that the LEDs turn off, so we add another cycle to decrease it. The first argument is that it starts from the last LED. In this case, we subtract 1 because LED 8 is on pin 7. We want the cycle to stop when all the LEDs have turned off. In this case, it's higher or lower, same as 0. And finally, it decreases. In the same way, the waiting time is 0.1 second.
And this is the final result of the exercise 2.
Our challenge will be that the LEDs light up by color. We respect the declaration of variables and the body of the void setup, since we are going to continue using the same LEDs. As our array comes from 0, we are going to take into account the first LED as 0 and so on, so that the 0 number and the even numbers are the red LEDs and the odd ones the green ones. We carry out the first cycle to turn on the LEDs, in this case the odd ones. For this, we will use an if conditional. Before continuing, we know that the difference between an even and an odd number is that the even numbers have a remainder of 0 and the odd numbers are not. So our condition to identify if it is even will be that its residual is 0. If so, you can turn on the even LED and wait 0.09 seconds so that we can see that the red lights up first, and later that it turns on, it turns off. Now we repeat the same cycle to that it returns to the first LED. In this case the LEDs will decrease, that is from LED A to 1. When the above 4, we are going to continue with the green LEDs, therefore their residual is different from 0. We do the same procedure so that they return to the first LED.
And this one is the final result of our challenge. This is the importance of the control structures, to reduce our program and to help use condition it. In the next practice we will make a roulette of loop with LEDs, so control structures will be necessary.
Attention! Before you go, don't forget to leave your like and your respective comment about the video. Thank you very much and see you soon to make un ingenio más.